Okay, we asked this question from our previous channel, which I told you that I'm going to solve a question to clarify you on how you perform binary subtraction using 1's complement and 2's complement. I will solve this question, and in the next video I will give a question as an assignment or as a classwork for I to solve later, for you to know your capability in performing binary subtraction using 1's complement and 2's complement. Okay, let me start with the first complement of this question. They say subtract 11011 from 11111 into 6 places. Yes, I'm correct. Using first complement and 2's complement, which is, I'm going to start with the first complement, which I told you about. I'm going to start with the first. I'm going to start with the first complement. Okay, and you know, in this solving this thing, you have to know your A. Let's say to subtract this from this, to subtract this from this, and you remember in our previous steps that told you that if you are given two numbers, which is A and B, you are required to subtract B from A. First of all, you have to know which one is your A in this question, and the one that you are subtracting from is what is your A, which is your A is 111 into 6 places, and the B is 11011. Okay, and the second step, the first step told you that you have to make sure both of the A and B are the same, and you have to notice that A and B are not the same. And how will you do it right now? You have to append 0. And where are you appending 0 at? That is the next question. Where are you appending 0 at? You are appending 0 at the extremes. Yeah, look at now, this question will now be 0 0 1 1 0 1 1. So you have to know the first complement of the substring. The substring, which I told you, you have to know the first complement of B, which is the second step. The first complement, you have to know the first complement of B, and you know that first complement is interchanging the values given. That means the first complement of 0 is 1, the second complement of 0 is 1, the first complement of 1 is 0, first complement of 1 is 0, the first complement of 1 0 is 1, the first complement of 1 is 0, the first complement of 1 is 0. Then what the next step, which is the third step, you have to add this with this. Are you understanding? You have to add this with this, and it's going to be 1 1 1 1 1 1. You are going to add it with this is 2 4 2 4. I made a mistake, rather this thing is 5 and I appended 0 twice. You're going to remove this, you're going to remove 1 from this, which is going to be complete. Sorry for the mistake. 1 1 1 0 0. Now what happens right now? You have to perform your binary arithmetic operation addition, which I've earlier teach you before. 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is 2, and remember you are on the base 2, you have to divide it with 2, and it's going to be 1 remainder 0. You're going to write the remainder here and carry 1 here, and it's 2 already. It's going to be 0 carry 1, and it's 2 already. It's going to be 0 carry 1. It's going to be, and you know that this is 3 now, because 1 plus 1 is 2 plus 1 is 3. It's going to be 2 divided by 3. It's going to be 1 remainder 1, and you're going to write 1 here and carry 1, and there is an invisible zeros here, which is, if you plus it, it's going to give you 1, and this is your answer in the step 3. Your answer is this from the step 3, and remember what I told you concerning end carry and the extra digits. And remember, we have 6 digits here, which is 1 2 3 4 5 6 and 1 2 3 4 5 6, and at the final answer we got 1 2 3 4 5 6 7. There's an extra digit here, and that extra digit here is called end carry. This is called end carry. But in first complement, the digit is not discarded. You remember, the digit is not discarded. And what you will do right now is, which is the fifth step, that tell you if there is no end carry, the result is negative. If there is no end carry, the result is negative, and we again obtain the first complement of the result to get the final answer. But the first step told us that if the result of the addition has an end carry, which we have an end carry right here, and bring it down, that told you to bring it down and add it to the last bit. You are going to add it in this bit right now. Look at what they are talking about. The end carry, you just discard the end carry, not discard it finally. 1 0 0 0 1 1. You're going to add the end carry here. You're going to bring the end carry to the last digit, which is the significant bit. You're going to add it here. It's going to be here. This plus this is going to give it 2, and 2 divided by 2 is 1 remainder 0. It's going to be 0 here. You carry 1, which is 0. Carry 1. This is going to be 1 0 0 1, and this is your final answer. This will be your final answer. And remember, the last steps told you that if there is no end carry, if after solving this question right now and you get the same digit of the question, the same number of digits, and which means that there's no end carry after solving it, and that means that the result is negative, what you do after is to find the first complement and get your answer. Okay, let's go to the second question, which is performing the same arithmetic, performing the same stuff with the same operation using second complement. 1 2 3 4 5 6. Yes, I'm correct. Plus 1 1 0 1 1. You are going to perform this with second complement, and you remember the rule of the second complement that I told you. The first rule is always the same. Ensure that both of them have the same number of digits, and you know that here is missing a digit. We are going to append 0 here to make sure that the first one and the second one are complete. Then it will now be 1 1 1 1 1 1 plus, I will append 0 to the b. Yeah, this is minus, sorry, we are subtracting, but we are using a binary. We are using binary subtraction using second complement. I'm going to append this here 1, and what it returns out, and you know that this is your A and this is your B. You are subtracting this from this. Okay, you are going to find the second complement of this. You're going to find the second complement of B, and the second complement of B, you have to find the first complement of B before finding the second complement of B. And the first complement of B, the first complement, some people call it 1 complement, is going to be 1 0 0 1 0 0, and the second complement, which I've earlier discussed, you're going to add this with 1, which will give you second complement. This will be 1 0 1 0 0 1. This is the second complement. That means after finding it, you are going to add this with A. You're going to add the second complement with A, which is 1 1 1 1 1 1 plus 1 0 0 1 0 1. All are in base 2. Remember, once you perform the operation right now, it's going to give you 1 plus 1 is 2, and remember, we are considering a base 2. We are considering a base 2. It's going to be 2 divided by 2, which I'm sorry for the interruption so far. Let's continue from where we stop. We stop here. Here is going to be 1 plus. I'm sorry, I will continue from where I stop. Sorry for the interruption. 1 plus 1 is 2, plus the other one is going to be 3, and 3 divided by 2, which is you're going to divide this 3 with 2, is going to be 1, remainder 1, and going to be 1. And remember, you're going to write the remainder and carry the 1. Remember, there is an invisible zeros here. You're going to, now this is the answer, 0 plus 1, which is 1. Now this is the answer, 1 1 1 1 0 0 1 0 0 2, which is the second complement of the binary subtraction using the second complement. This is the answer. And remember, in the first three, in using second complement, you have to discard this. That means our answer will now be 1 0 0 1 0 0